Systems of equations. All right, we're going to be learning how to solve systems of equations. And there are three methods that we're going to learn: the addition and subtraction method, the comparison method, and the substitution method. Okay, so the first thing we're going to look at is the addition and subtraction method. All right, so here we have an example. We have negative 2x plus y is equal to 3, and we have 2x plus 8y is equal to 6. Okay, and if we add these together, the x's will totally cancel. Okay, so let's try to add these. We're going to use addition. So the negative 2x added to the 2x gives us 0. The y added to the 8y gives us 9y. The 3 added to the 6 gives us 9. Then if we divide both sides by 9, you get y is equal to 1. All right, we can feed that back into either equation. It doesn't matter which one. And so I'm just going to take the bottom one. And so we have 2x plus 8 times y, and the y is equal to 1. So we have 2x plus 8 is equal to 6. So I'm going to subtract 8 from both sides. And that gives us 2x is equal to negative 2. Divide both sides by 2, and that gives us x is equal to negative 1. All right, here's another example. You have 2x minus 3y equals 6, and 2x plus 8y equals 6. Now, here the two x's, the coefficients are the same. So what I'm going to do is I'm going to subtract them. Okay, so if the coefficients are completely opposite, you can add, but if they're the same, then you can subtract. Okay, so I'm going to subtract. So 2x take away 2x is 0. And remember, to subtract, you're adding the opposite. So you can change this to add by just changing the sign of every single term. Okay, that's another way of doing it. So 2x take away 2x is 0. X and negative 3y take away 8y is, well, you have negative 3y and negative 8y. You're going to put those together, negative 11y. And then 6 take away 6 is 0. So we have negative 11y equals 0. Divide both sides by negative 11, and that gives us y is equal to 0. So we're just going to feed that back into one of these equations. So I'm going to take the top one, 2x minus 3 times 0 is equal to 6. So that gives us 2x equals 6. Divide both sides by 2, and x is equal to 3. Okay, so our solution here is x is 3 and y is 0. All right, let's go and look at our second method, which is the comparison method. So here we have y equals 2x minus 7 and y equals 1/2 x minus 1. Now, this is the one you use most often if you have the y isolated, okay, or the x isolated. You could do that too, but more often than not, the y is going to be isolated because these are, okay, or functions of x, but it's like, you know, f of x is equal to 2x minus 7, that kind of thing. So often the y's are already isolated for you, and so we can say, okay, y is equal to 2x minus 7, and y is equal to 1/2 x minus 1, so 2x minus 7 must be equal to 1/2 x minus 1, okay, when these two lines are equal, or when these two equations are equal. So 2x minus 7 equals 1/2 x minus 1, and then I just want to solve. I want to get rid of that 1/2, so I'm going to multiply everything by 2. That's one way of doing it. Okay, so when I multiply everything by 2, the 2 times 2x is 4x, the 2 times negative 7 is negative 14, the 2 times 1/2 x is x, the 2 times negative 1 is negative 2. All right, so I want to get all my x's on one side. I want to get rid of that x, so I'm going to subtract x from both sides. So that gives me 3x minus 14 is equal to negative 2. And now I want to get rid of that negative 14, so I'm going to add 14 to both sides. And that gives us 3x is equal to 12. All right, now the only thing stopping the x from being alone is this 3, so we're going to divide both sides by 3. And that gives us x is equal to 4. Okay, then we're going to feed that back into one of our equations and solve for y. So I'm going to take the top one because it has no fraction. But even if I take the bottom one, 1/2 of 4 is 2, take away 1 is 3. Whoops, 1/2 of 4 is 2, take away 1 is 1. Doesn't matter which one you pick. So 2 times 4 is 8, take away 7 is 1. So you're going to get 1 in either case. Okay, so y is equal to 1. So x is equal to 4, y is equal to 1 is your solution. Let's try another example. Here we have x is equal to 3y minus 6, and x is equal to 2y plus 1. In this case, we've isolated the x's. So that means that 3y minus 6 is equal to 2y plus 1. Okay, so 3y minus 6 is equal to 2y plus 1. And by the way, it's in terms of, like, you know, when you draw these as lines, it's at one point they actually coincide, right? So if let's go and have a look at our line making machine. Okay, you end up getting two different lines. They're not always equal, but at one point they are equal. So right here, if you look at it, it's when the x is equal to 15 and the y is equal to, yeah, 7 and 15. Okay, when x is 15, y is 7, so 15, 7, they're equal. Okay? Okay, so back here. So what we're saying is 3y minus 6 must be equal to 2y plus 1. Okay? And they're equal at that one point where the two lines coincide. All right, so I want to get all my y's on one side. I have more y's on my left-hand side, so it's easier to get rid of the two y's. So I'm going to subtract 2y from both sides. And that gives us y minus 6 is equal to 1. And then I'm just going to add 6 to both sides to get rid of that minus 6. And then I'm going to, that gives us y is equal to 7. All right. Then I want to solve for x. So I'm going to feed this back into one of these equations. So I'm going to pick this one. So 2 times y is 7. So 2 times 7 plus 1. So I replace the y with 7. So we end up with 14 plus 1 is 15. So x is equal to 15. So our solution here is 15. When x is 15, y is 7. Okay. And that's it for the comparison method. All right, the last method is substitution. The substitution method. And here I have y is equal to 4x minus 14, and here we have 3x plus 2y is equal to 5. And this one is really useful for like when you've isolated one variable. Okay? So if we have, what I'm going to do is I know that y is equal to 4x minus 14. Okay, so what we're going to do here is, we know that y is 4x minus 14, so I'm just going to replace the y in the second equation with 4x minus 14. Okay, so I'm rewriting the second equation out, so we have 3x plus 2 times y, but y is 4x minus 14, so I replace it with brackets 4x minus 14. Remember from grade 7 we replace into brackets? This is one of the reasons why. So we have 3x plus 2 times 4x minus 14 is equal to 5. The 2 comes in multiplying the 4x, giving us 8x, and multiplying the negative 14, giving us negative 28. All right, I want to add my like terms, so the 3x and the 8x make 11x. And I also want to get rid of this 28, so I'm going to add 28 to both sides. So that gives us 11x is equal to 33. Now I want to get rid of that 11, which is multiplying the x, so I divide both sides by 11, and x is equal to 3. And then I'm just going to feed that back into my equation up here. So y is equal to 4 times 3 minus 14. Okay, and that gives us y is equal to 12 minus 14, which is negative 2. So your solution is x is equal to 3 and y is negative 2. Let's do another example. Here we have x is equal to 3y minus 3 and 5x minus 2y is equal to 11. So I'm going to replace the x from the first equation into the second equation. So instead of writing x, I'm going to write bracket 3y minus 3. Okay, so I have 5, open bracket, 3y minus 3, close bracket, minus 2y, so that's the minus 2y is equal to 11. Then the 5 is going to come in, multiply the 3y, and multiply the negative 3, giving us 15y, and 5 times negative 3 is minus 15, minus 2y. I'm going to add my like terms. The 15 take away the 2y is 13y, so I'm left with 13y minus 15. 13y minus 15 is equal to 11. I want to get rid of that minus 15, so I'm going to add 15 to both sides. And that's going to give us 13y is equal to 26. I want to get rid of the 13, which is multiplying the y, so I'm going to divide both sides by 13, and that gives us y is equal to 2. So I'm going to feed that back into our equation up here. So I picked the first equation because it's easier, because we have, once we replace what y is, we'll have our answer. So x is equal to 3 times y minus 3 becomes x is equal to 3 times, now the y is 2, so 3 times 2 minus 3, which is 6 take away 3, which is 3. So x is 3. Okay, so our solution is x is 3 and y is 2. And that's it for systems of equations. Have a good day.